More practice finding angles based on trig ratios. Let's see what they've given us this time. First of all, they expect us to speak radians. If I say stuff in degrees, I apologize. I'll try to catch myself and fix it right away. So, sine theta is 1/2. Where are we if sine is positive 1/2? Sine corresponds to the y-coordinates, so it should be in the top two quadrants. Not here. Not here either. So there's one of our possible triangles, and here's the other. Now, you could go to the calculator and do the second sine of 0.5, and it'll tell you that this angle is 30 degrees if you've forgotten to change your calculator setting. Or you can look at this and say, okay, sine is opposite over hypotenuse. That's the so in SOHCAHTOA. And so our opposite side is 1, our hypotenuse is 2, and then you go, hey, wait, I know this triangle. This is root 3, and this is a 30-degree angle. This is one of the specials that we hope you'll memorize. And in this other quadrant, the exact same thing happens. 1, 2, and, well, it's negative root 3 because we're off to the left. And again, a 30-degree reference angle. So either with technology... Oh, I did it, didn't I? Sorry about that. I said 30 degrees. We're supposed to work these in rads, so forgive me while I sort myself out here. When I said 30 degrees, of course, I meant pi by 6 radians. That's our reference angle when we're working in rads. Okay, so we have reference angles of pi by 6, and now from those we have to get rotation angles. Our first rotation angle is right here, and we're in quadrant 1, so this one's easy. It really is pi by 6. There we go. The second one would be come all the way around to pi, and then back up pi by 6, which leaves us with 5 pi by 6, or 5/6 pi if you prefer. So those are two exact values. They said exact, which means we don't want decimals here. We have to give them things with pi in them. And mission accomplished. Secant theta is minus root 2. Secant theta is not our friend. Let's see if we can fix that. The reciprocal of secant is cosine theta. And that will be minus 1 over root 2. So I'll do these next two a little bit faster because I think you're probably getting the gist of this procedure by now. What quadrants are we in if cosine is negative? The two where x is negative. We're not here, we're not here. Our triangle looks either like that or like that. It has an adjacent side of negative 1 and a hypotenuse of root 2. Recognize this one? This is the 45 triangle. And, boy, I keep doing that, sorry. I said 45 degrees. Of course, I meant pi by 4, because we're in radian mode now. You can get away with doing most of your thinking in degrees if you're more comfortable that way, and you can. That's quite obviously what I'm doing, but as long as you remember to write the appropriate values in your sketches, you should be all right. The more you can get yourself to think in radians, the smoother this will go, but it is possible to get away with doing a lot of your mental processes and even the work on your scrap paper in degrees and then just convert when you must. So, reference angles of pi by 4, either above or below the horizontal. And so that means our rotation angles are either here, which is pi minus pi by 4, or all the way around to pi, and then an additional pi by 4, which takes us to 5 pi by 4. Okay, cosecant now. Undefined, you remember how this goes? Undefined, when you're doing a trig ratio, really only means one thing. It means we had something or other divided by 0, and that's where the undefined came from. But that's not so bad if we flip this over. The reciprocal of cosecant is sine theta, and the reciprocal of some number we don't care about over 0 is 0 over some number we don't care about, and that's plain old 0. So we got out from under that undefined problem. So where are we if sine is 0? Remember, sine involves the y-coordinate. So if sine is 0, we must be either right here at 0 radians, or we must be off here to the left at pi radians. Actually remembered to do radians that time. So, while there's no rotation angles to work out, we already found them because we're right on the axis. The answers here are going to be either 0 or pi, or I notice up here we're allowed to have 2 pi, and that's another version of 0. So 0 pi and 2 pi will be our solutions here, all the places where we're exactly on the x-axis.